So we've been talking about polyatomic ions all along. Here's the list of polyatomic ions that you need to have memorized. It's not too bad. It's definitely manageable for making flashcards or note cards with. Okay? Or if you want to just rewrite them as many times or sort them by charge or whatever. Okay? But what you need to have memorized is the name, its formula, and its charge. Those three things are equally important. Okay? If you mess up the charge on a polyatomic ion, your formula is going to be wrong. So if you mess up how many oxygens each of those have, its formula is going to be wrong again. So notice several of these end in 8. Okay? 8 doesn't have one particular meaning, okay, beyond just multiple oxygens usually. Okay? Because some 8s have 3 oxygens, some 8s have 4 oxygens. Okay? You know, there's phosphate and sulfate compared to carbonate, chlorate, nitrate. Okay? Acetate is totally different. So you do kind of have to memorize what how many oxygens each of those has. One thing that can possibly help just a little bit is looking at a periodic table. Here's just those elements there are involved in polyatomic ions with multiple oxygens added. So there's an 8 version of each of these on the list: carbonate, nitrate, phosphate, sulfate, chlorate. They form a nice, neat pattern if you write their little formulas. So carbonate, CO3, 2 minus, nitrate, NO3, 1 minus. Okay. So you see those two already formed a nice little pattern. If I go down from there to phosphate, PO4, 3 minus, sulfate, SO4, 2 minus, chlorate, the O goes down by 1, but based on a periodic law here, you can probably guess what the charge of chlorate would be. See how that works? Okay. So the other slightly handy thing here is that P, S, and Cl have the same charges as the monoatomic ions do: phosphide, sulfide, and chloride. Those are ide. These are 8. These are 8, too. Okay. Carbonate and nitrate are different from their ides. There is no carbonide. Anyway, there's no 4 minus. But nitride is 3 minus. So it does form a nice little pattern that way. So if you're sort of a visual person that likes to map that out, that's a helpful way of looking at it. Okay? But I think what's just helpful for a lot of people is doing it sort of language-based. I guess it depends if your brain responds a little better to language or to verbal or to patterns or whatever. You know, figure out something that works for you. For a lot of people, if you have flashcards with the formula on one side and the name on the other side, you just get used to saying sulfate, SO4, 2 minus, phosphate, PO4, 3 minus, you know, something like that. So, and then actually using them, practicing making compounds out of them is even more helpful, I think, because then it's in context and you really get used to doing it. Okay, so for all of these 8 ones that I've underlined, okay, there is a related ite ion, okay, that just has 1 oxygen removed. So let's write those. Okay, let's write chlorite. ClO2, but the same charge. Okay. Nitrite. NO. What? 2? 1 minus. So nitrate and chlorate are really very similar. Okay? Nitrite and chlorite are really very similar. Phosphite. PO3. What charge? Yeah, same charge. Okay. Sulfite SO3, 2 minus. Okay, so that works. So I don't have those on the list because you automatically know either way. If you run into an ite, it will have one fewer oxygen than the 8 that you memorized. Okay. If you run into something like NO2 with a 1 minus charge, you will know that that's one fewer oxygen than the NO3 1 minus that you memorized. Okay. So put a little work into that, put some time into that, put some practice into that. That's going to be very important because all throughout chemistry, we refer to compounds interchangeably between their names and their formulas. Okay? So you need to know how to do that. You need to know the difference between sodium nitrate and sodium nitrite. They're two totally different compounds that have very different properties. So, what else? Addition of H reduces the negative charge by 1. Got one example of that up on here with carbonate and bicarbonate. Okay. Bicarbonate is sometimes called hydrogen carbonate for that exact reason, but it's HCO3 single minus. Okay. If we just take carbonate, we add an H to it, that charge gets reduced, okay? Because it's actually an H plus that gets added, a hydrogen cation that gets added. Okay? And when we talk about acids and bases, that's a very important reaction that happens, adding a hydrogen cation to something like that. Okay? So bicarbonate, HCO3 1 minus. Here. Let's do bisulfate or hydrogen sulfate. What would that formula be? Okay. When you got a 2 minus ion, you have room for just one H to be added, and it's still to be an ion. Okay? If you totally neutralize it with H's, then you end up with an acid, and we'll talk about those later. That gets named differently. Okay? But with phosphate, phosphate's different because we've got 3 minus. So we could add 1 H and get a certain charge. We could add 2 H's and also get another charge. So sometimes, a lot of times those are called monohydrogen phosphate. And dihydrogen phosphate. So monohydrogen HPO4. What charge would that one have? Yep, because we started with 3 minus. Okay, monohydrogen phosphate. What would dihydrogen phosphate be? H2PO4 with what charge then? Yep, single minus. See how that works? Okay. Now, I'm going to show you a series of these. It's called oxyanions when it's an element, some nonmetal plus a certain number of oxygens. Let's say X oxygens, and some kind of negative charge. Okay. Most of our lists there are oxyanions, okay, with the exception of ammonium. That one's plus. But if we have more than 2 oxyanions in a series, like I showed you ClO2 and ClO3, but it turns out there's more of the chlorine ones. There's just regular ClO, and then there's ClO4. Okay? The middle two are ite and ate. Chlorite, chlorate. Okay? But going beyond that in either direction, okay, that's where we use hypo and per. So chlorite with even one fewer than chlorite, that's hypochlorite. Hypo means below or under, like hypothermia, means your temperature is too low, or a hypodermic needle goes below the surface of your skin. Okay? Hypochlorite. So then, what would ClO4 with 1 minus be called? Perchlorate. Okay? So, chlorite became hypochlorite. Chlorate became perchlorate, going one beyond that. Okay? So, this same series is exactly the same for Br, BROX and I. Okay. X equals 1 to 4, so they're named the exact same way. So hypobromite all the way to, yep, bromine and iodine are the only ones that make that this particular four series of 4 ions. Okay. So, and the charges are the same and the names are the same, okay, for all those. Okay. So, let's do a couple compounds that have polyatomic ions in them. What is the ratio of ions present in CuSO4? Obviously, there's one copper there. So 1 copper for every what? 1 sulfate ion. And again, if it's helpful to make a little bracket around there to remember that SO4 is a group. It's an S connected to 4 O's. All of those polyatomic ions on our list are treated as groups that don't come apart. Okay? So CuSO4 is a 1-to-1 ratio. It is not a 1-to-4 ratio. It is really not a 1-to-1-to-4 ratio. Okay? That's not meaningful at all. So we have to break up what the actual ions are. So copper, variable charge. SO4, though, from your list, we know has what charge? SO4 from our list, we know has 2 minus, just like regular S2 minus does. Okay? Because it's a 1-to-1 ratio, what copper charge do we have in this case? Yeah, we got 2 plus. Whenever it's a 1-to-1 ratio, our charges are the same, right? So the name of this compound is copper. Copper sulfate would get you like half credit, something like that. Maybe 2/3 credit. Copper 2 sulfate. And again, doing the ions is so critical for that because the name of this compound is absolutely copper 2 sulfate. There is no number 2 anywhere in this formula right here. Okay? So unless you totally got this down and can do this whole process in your head, you absolutely every single time have to write out what is the plus ion with its charge, what is the minus ion with its charge. Okay? Why don't you see if you can do it with these two? Here's a name. Okay? So start with the charges. Okay? We actually gave you this Roman numeral 2 here, so that gives you a little more information already this time. compare them with your neighbor. See if you got the same thing. For all your little numbers and your parentheses and everything. Let's see if we got the same thing. And if you can't immediately tell me what the symbol for cobalt is, or what the name for Mn is, then you got a little bit of elements, names and symbols to be practicing up on. A lot of you are probably okay on that, but some of you go look. I have a sheet. It's in handouts in D2L. Print that off. Practice those if you don't know those. That's kind of important. So one mistake that I'm seeing a good amount of is involving ite. Ite has a particular meaning. What does ite mean? You need to remove one oxygen from the what? From the 8 on the list. Okay? So if it's ite, you need to go to the list, find the 8. Remove one oxygen from the 8. That's what ite is. Okay? Don't confuse that with ide, which is just the element alone. Okay? Chloride, like sodium chloride. Okay? Ide is the simplest one. That's just the element alone. Okay? Ite and 8 have a certain number of oxygens to them. You need to memorize the 8 because they're more common. Okay? We run into the 8s all the time. Every once in a while there's an ite, though, that has one fewer oxygen. So actually I don't need a box there because how do I know what charge cobalt has in this one? It tells you right there. You would be shocked to learn how many students ignore the charge that's given to you right there in the name. So if you're ever given a name, if it has a Roman numeral, that is automatically the plus charge. So don't make that harder than it needs to be. You need to figure out the plus charge if you're given a formula. Okay? Because you know what the minus charge is, you have to use the formula to figure out what the plus charge is. Okay? If you've given a Roman numeral there, it's just right there. All right, so what is nitrite then? It's NO2, 1 minus. Okay? If you wrote N3 minus, that's not right. What is N3 minus called? That's nitride. That's not what we want here. Okay? We want a nitrite. Okay? So CO for the formula, CO NO2? Oh, parentheses 2. There you go. Make sure in your formula all of your numbers are down in the bottom. Okay? Should have no numbers up on top here because those are for the charges. Okay? Neutral formulas have no charges. All right. Here's one. I will put a box. We're going to have to figure this one out. So let's move on. Let's do PO4. We know PO4's charge from our list. PO4 is what? Okay, it's 3 minus. Now look at our formula. Here's PO4. There are 2 of those PO4s in the formula and just 1 manganese here. So what should I put in the box? I should put 6 plus in the box. And I should call this what? Manganese Vi space okay. Manganese 6 phosphate. What I want to show you in D2L here, if it ever comes up, thank you. A couple things. Content. Practice worksheets. All right. Several that involve naming. Okay. Variable charge compound names, variable charge compound formulas. Those two are pairs of each other. So this one is just a big, huge, long list of names that you have to write formulas of. This one is that same long list, but it's formulas that you have to write names of. So you use those two as keys for each other, but be able to go both directions. Okay. These are compounds that contain polyatomic ions. Okay. Some are fixed charge, some are variable charge. Okay. Should be able to write their formulas. So big long list, just pick some from here or there, or you do little blocks of them, whatever. In links, yeah, I'm going to put something up in links. There's a website called Quizlet that lets you make online flashcards that one of my students showed me a year or two ago. We worked a year ago as a class to make a set of Quizlet type groups that have different naming exercises. So some are just the ions, but some are actual names and formulas. So it's a link for practicing for all that sort of stuff. So I'll put that up in links right there. We will continue on with this next time. We'll continue with naming and practice and then do some more calculations.